Hi, today I wanted to make my own independent random number generator because I was searching the documentation and noticed that this note that it says the underlying algorithm for the random number generator is an implementation detail and should not be depended upon. What does this mean? It means mainly that if I rely on the engine generator or the random number generator, it could be changed in future versions of the engine. So it will change the shape of the. Let me show you. I'm making random decisions to make the shapes to choose what levels to use from the from the data bag, the level bag, and then multiple random decisions about the paths I will use to connect the levels, etc. So for any determined seed I use for the game, it could change a change in algorithm could change the aspect of the game and potentially ruin the save files of the players. So I made this task and I was looking for nice pseudo-random generators which use 32 bits of state because the problem with some of the generators I used in the past is that they use 64-bit, and the int class in the engine it uses only 63 bits because it is sign. It uses 1 bit for the sign and 63 for the actual values. So I could not use some of the generators I'm accustomed to. So I will try to use this suggestion here because it seems interesting, but I will check it later. You will see. Okay, let's make a new script. Let's call it RNG. Class name RNG. Let's use let's see, this code obviously is in C++ or in C, so it will let's call it max value, and return an int, and let me see, bar set equals to the state. This should be making this in a separate line. Let's use a state. Okay. We need to see let's use this. Okay, let's see, this is this makes a shift and multiplications. Okay, and we need to return only 32 bits, so I will end the result with this value. This value are 32 1 bits. Okay, now let's make testing scene, 3D scene. Let's save test RNG. RNG test. And let's put a script here. And let's make let's see it with 42, and let's test this for example, next value. If we run, we need to run only the test scene. What happens? We must create, obviously, the RNG. Okay, we have some values here, but the problem with this kind of random values or pseudo random values is that we are not very sure about the quality, because in this this suggestion here is from a total stranger, so we will use a tool called Dieharder, because it's another version of an old statistics testing suite named Dieharder, but this Dieharder is more modern. Let's see. We need an input file, raw binary or format ASCII. Let's see, this save file name generators 201 and 202. We need to have a binary file, so let's do that. I think, yeah. Right. And instead of printing how is this? Get store 32 value. Okay, so if we do this, I think let's see, output. Why is this? Let's open the file to check. I was checking before some of these advanced algorithms, but they need at least 64 bits to be useful, so let's close the folder. Okay, I have this output open. Okay, it seems to have binary data. We could check it out. Yeah. Okay. So how it was the generator? We need to tell it to run all tests. Okay, we are failing some of the tests, but this is because we have only 3 kilobytes of data. So let's generate at least 4 megabytes. No, this is the wrong folder. Output. We should quit after we generate. It's fast. 3.8 megabytes of data. It's not very good, it seems. These statistical tests are very interesting these are generators. The tests let me see. Let's try another. Water. We are not seeding it. Yeah, we are seeding it. What could be? Because, sorry, output. Yeah, we have data, but perhaps it's too small. Let's generate more, 10 times more, and this could work. Let's see, this is now 40. Interesting. Perhaps we are passing the second test. Yeah, these tests require many bytes of input to work. Let's see if this, random entities. Some tests have fixed sample size. Sample. how many samples could we need? Let's generate these are 100 million. This will take a bit, so I will pause the recording here. Okay, we have our new file, 381 megabytes. Let's see if we pass the tests. Pass the second test. The this test is interesting because it's related to the birthday paradox. Sorry. I was reading the birthday spacing and the birthday paradox related to the classic paradox about the probability of having two people with the same birthday among a set of people. But it is interesting. Check it out if you can. Okay, we are passing some of the tests and failing many. So perhaps our translation of the algorithm is not so good. Let's see. We are coding perhaps Godot. This is the problem, perhaps. Look at this. Obviously, this is 32-bit, but this is only 24. This is embarrassing. Okay, let's generate 10 million samples. This should be fast. And let's test again. The problem, if you I did not explain this, but I was generating only 24 bytes of entropy and sending to the file 32. So always approximately a quarter of the bytes were set to 0. That's why the statistical tests fail. This is different. We are passing. Failed the second now. Interesting. We are rewinding the file because it has too few bits for this test. Okay, let's generate the big file again. I will pause here. Okay, we have again the large file. Now we should pass at least more tests. Okay, Dieharder birthdays passed. Dieharder this could be related to permutations. I don't know. I'm not sure. This pass. I will pause the video to let the tests run. Okay, it's still going after some minutes, but it's doing well. It seems to have passed the majority of the tests so far. There are some that return a weak result, but like this one, but the majority is passed. So I don't know. Perhaps I will let it finish because I'm not sure how many tests there are in total. But for now, I will let it crunch crunch the numbers, and for now I think I will end the video. This kind of thing seems a bit esoteric, perhaps for many game devs, but they sometimes there are games that depend too much on the specific implementation of these things. That's why I decided to not depend on the internal version of the random number generator, because as they say here, the underlying algorithm is an implementation detail. So you never should depend on that if you want, like I need for this project, if you want repeatability of the random results. So I will enhance this code, add some more functions to generate random values in a useful range, for example, and obviously replace all the mentions of the engine's random numbered functions, replace them with my own, but I will do that later. For now, thanks for watching. Wish me luck with the rest of the tests. Please like and share the video with people that could learn or enjoy with this kind of videos. Thanks.